I'll show you how to create a movie file from a number of the data file snapshots. So what I'm going to try to do is to create the movie something like this. So if I do the preview, then this is a movie from one of the simulations that I did for electrokinetics. So the axis and contour and all these texts, as you can see, they are formatted in the same way. And what I'm going to do is that I'm going to create the old snapshots or old still pictures, then so that I can merge them into a movie file. Okay. So to do this, I need 4 different files. First is the data file. Second, layout file, ending with the LAY in Tecplot format, and macro file, which I talked about in the previous video. And I need this shell script, which execute everything. First, the data file. So if I double click this folder, and you can see 3 different PLT files, all written in Tecplot format. And they have some numbers here, and that number increases by 10,000, meaning that I wrote this file every 10,000 time step. And I'm assuming that the computational time step is the same. So the physical time between this file and this file is 10,000 times the computational time step, which will be used later, but probably I'm not going to talk about this. I have only 3 files, but in reality, you're going to be given like 1,000 files. So the bottom line is that you don't want to create the movie manually. Basically, you want to automate the procedure so that you can just edit the file, the text file, then you update all the files, then simply execute the shell script so that you can create the movie. So let me show you what I have in this data file. So Tecplot is launching. So this is the data file. Unlike the movie that I show you, it's not really formatted in any way. Okay, so uncheck the shade and contour, and here I am visualizing the velocity in the x direction. So this looks quite different from the movie that I show you. So it's your job to prepare the layout file so that the visualization looks similar to what I show you in the movie. So this given this data file, what we typically do is to, for example, rotate the axis, for example, for this particular problem, then, and I can change the contour variable from u velocity to, for example, okay, maybe something else. I don't know what this is. Okay, divergence. Oh, okay, this is velocity divergence, something like this, and you can change the, for example, the font. Right now, the default font is Times. Maybe you can change it to something else, or you can see that the format of the numbers are changing, something like this. Then you save it, save the layout file. Okay. So this is what we do. So here in this data file, I have 10 different variables. The first 2 are the x and y axis. So the remaining 8 variables correspond to the solution variables. So this is just a brief introduction about what the data file contains. So, but again, like I said, when you read the data file, all this, like all the outlook of the visualization, it's not really defined. You need to define it yourself. So here I did it myself. So that's the layout file you can find here. Here, this is the visualization of a variable C, and this is the visualization of the variable rho. This is called the charge density in the electrokinetics. So this layout file is nothing but a text file. I cannot really move around. Okay. Open with BBEdit. So this layout file is nothing but a text file. It reads a data file. I changed the name for the reason I'm going to talk about. Then this layout file contains all the instruction um, with which the data file, the visualization is formatted. It might be difficult to understand what this is, but this is for the Tecplot, not for human. So to run this, the layout file, we need to have this data file. So this is actually a placeholder for one of the data files shown here. So I'm going to copy one of these and put it in the same directory as the layout file. And I'm going to rename this copied data file in the same way. Then the next thing I want to do is simply execute the layout file using a Tecplot in this case, by simply double clicking. And you can see that we can have the exactly same outlook as the movie. So you can do the same thing for charge density. So here I already set everything. So this is the charge density visualization for the same data file. Okay. So layout file and macro file, I already talked about it. So if I open up the layout file, this is actually quite short. What it does is that it opens up the layout file and it writes the what you see in the screen on the screen into a graphic file, temporary.tif. Okay, and finally the macro file terminate the Tecplot. So you can see that to execute the layout file, you need a data file. To execute the macro file, you need a layout file. And what needs the macro file to create all this movie? That's the shell file. So this file is important because it has all the instruction of. I cannot really drag and drop the. Okay. Let's see if I can. Oh, yeah, BBEdit. So this shell script is important because it tells the Mac what to do, not just Tecplot, all types of the other instructions. So there are six different command line argument. What is the first time step? What is the last time step? What is the difference between the two consecutive data file? What is the physical time for the first time for the first snapshot? And what is the physical time difference between the two consecutive snapshots? And the last one is which variable out of the 8 variables that I show you in the data file we are visualizing. So if the number of the command line argument is not 6, then the error will be printed out and the shell script will terminate. And there are some pre-processing stage. So first we calculate the number of the samples, how many data files we have. In this particular case, we have 3. And in shell scripting, doing the arithmetic operation is actually very inconvenient. You can see that I actually did it at the 3 different steps. So you can take a look, and we need this special expression expr just to let the shell know that this is actually arithmetic operation. And I define the name of the macro file, which you can also see on the left-hand side in the Finder. So first, the shell script prints out how many data files we have. In our case, it has to be 3. And there is a counter which simply counts the data file. So it is initially 0 because we didn't read anything. And this step underscore CUR it's just a working variable for the time step. And as long as the counter is less than number of the samples, initially this number is 0, this number is a 3, so the condition within this square bracket is satisfied. So we execute everything within the this block. So the first thing is to get um, the expression for the current time step. Here you can see that we actually format so that all the digit for the numbers is 10. What I mean by this is on the left hand side, if you go, you can see that all these numbers 0, 0, 0, 9, 5, 0, 0, 0, 0, 0, they have 10 digits. So we want to be consistent in the formatting in reading the data file. So that's why I have this extra step. And using this formatted the string, so we reconstruct the name of the data file. The data file can be found under the directory named the data, which I have here. Then it starts with a cc underscore, right? Then there is the 10-digit time step. Then the extension is .plt. Then here I defined a temporary file name because in the layout file, this is the name of the file that I want to read. So then I reconstruct the name of the layout file depending on the variable that I want to visualize. Okay, and I also define the name of the temporary layout file, and I actually make the copy of the actual data file into the temporary data file, and I copy the temporary layout file into the actual layout file to the temporary data file. So the next step is only applies to this visualization that I did for electrokinetics. So if you're interested, you can take a look. But I mean, this is not really essential part of the creating the visualization. Then the next thing is to simply run the. Okay, I have to make it wider. The next step is to run the Tecplot. Here I'm executing the Tecplot macro file. So not the layout file or the data file, because I want to read the layout file and I want to print out the graphic file into some format. And we do need these two options. So we want to run in a batch mode. We don't want to get any control of the Tecplot session. We simply execute the layout file. Okay. Then here I remove some of the temporary files. Then the last job is that here to create the movie, we want to create more than one graphic file. So we cannot just leave the name of the graphic file into temporary.tif. So we have to reconstruct the name of the graphic file so that it contains the information about the time step. Okay, so I rename the temporary file into the actual name of the file. Then I increase the counter because we are done with the first snapshot. Okay, then I increase the time step, the actual time step shown in the data file name. Then the steps after the line number 58 is about how to merge the in this case the three snapshots into a graphic GIF file so that you can see actually it moves. Okay, there are some minor details that you can see here, but please take a look. It's not that difficult to understand. So after this short explanation, what I'm going to do is I'm going to show you one example about how to run this shell script. So to run the shell script, so you have ls-al. So we need to execute this sh file. There are a number of ways to execute this file. The easiest way is to change its permission. So change the mode, and user can execute this file. Then you can see that this X attribute showed up, meaning that, and the color changes, but it may not change, color may not change depending on your color setting of your terminal. So anyway, I'm going to execute the shell. Then you'll be able to see the error message, and we can execute it further because we didn't specify the 6 command line argument. So, and what is the first time step? Okay, how do I get information? We go into data file. The first time step is this large number, 9.5 million maybe. So that's my first time step. You have to match it so that you can correctly indicate the existing file. The last time step is 9.52 million maybe. Then the time step between 2 consecutive files is 10,000, as I briefly talk about. And first time, the physical time, I mean, for now, let's just pick any value. And time between 2 consecutive files, let's just use a 0.1. And which variable I want to visualize. So there are 8 different solution variables, but here I have a layout file only for C and row. So I want to choose the C, and there you go. I have 6 different command line arguments. Simply press the enter. Okay, so I have the error for some reason. Oh, okay, because oh yeah. So here I have a Tecplot 2019. So right now the script is made for 2018, so I need to change it. It depends on the application setup in your computer. So I will do the same. Okay, I can execute it again. Okay, why can I? Maybe it's not saved. Okay, let me see. Okay, so let me go to the application, Tecplot 360 2019 R1, and what do I have? Tecplot R1, content, macOS, Tecplot 2019 R1. Okay, oh yeah, this is actually the program, so that's why I get up. Tecplot, content, Mac, Tech. Wait, okay. I think I have that. So Gen movie sh. So I think this is correct. Okay, oh, I can execute. Right, you can see that the Tecplot is creating this TIFF file, and sometimes it is creating temporary layout file and PLT file. Then, okay, it's done. So this is the example movie. Then if I go to the movies, then there is a subfolder created. Then you can see this GIF file only containing only the 3 snapshots. Okay. And sorry for the hiccup when I was executing the shell script, but in fact, depending on your local computer setup, this line number 46 may have to be changed in the same way I did. Okay, so this is the location where the this highlighted path is where the Tecplot is located in my computer. In your computer, it may be different. So go to the terminal and go move to that directory to make sure that everything is the same. Otherwise, you have to change probably this year and the release number and so on. Okay. All right. So this is everything that I have today. So, right. See you next time.